Okay, Wildcats. Today we're looking at Friday, November 9th, solving radical equations on page 33. Now, this is going to be the last video for a while because on Monday, November 12th, we'll have CBA 2 review. Tuesday, November 13th, we'll have CBA 2 review. Wednesday and Thursday, November 14th and 15th, we'll have CBA 2. Friday, November 16th, there'll be a CBA 2 free response. Monday, 11/19 through November 23rd will be Thanksgiving break. So the next video will be on Monday, November 26th, and that will be on page 34. So with that, let's get back to Friday, November 9th, solving radical equations. All right, now your table of contents is updated. Let's take a look at the notes. Solving radical equations on page 33. Steps to solve radical equations. Step 1, isolate the radical. Step 2, raise both sides of the equation to the power equal to the index of the radical. Step 3, solve for the variable. You can either simplify, box method FOIL, or factor. Step 4, check answers. Okay, so if you would, finish your notes. Now your notes are finished, let's take a look at the examples. All right, example number 1. Now, what you want to do before you even get started is let's draw a line about this much space, maybe a little less right here, all the way down. And this is going to be where you check, okay? Now, you also notice that I added lines. You don't have to, but I recommend doing that at this point is drawing some getting some lines that will help keep your work organized. All right, now that you have the lines for that, let's also go ahead and come over here and let's leave space to check. Okay, because that's the last step in solving. All right, now let's get started on example 1. All right, example 1 says isolate the absolute value. So we're going to divide 2 by both sides, and this is the index here is 2. If there's not an index, you know it's 2. So square root of x plus 1 equals 14 divided by 2 is 7. Now, next step is we need to raise each to the index. So raise each to the second power. What happens here, and I think we talked about it in the previous lesson, but I'll go over it. If you had the square root of x squared, this can be rewritten as x to the 1/2 power, because this is 1 squared. Okay. Here we know we multiply that, so that becomes x is 2 over 2, so it becomes x to the power of 1. Okay, so that's what happens here. This becomes the power of 1, so you're left with x plus 1. 7 squared is 49. And then our last step is we subtract 1 from both sides, so x equals 48. Now, once you have that, you plug the number back in and check. So that's 2 square root of 48 plus 1 equals 14. Well, 48 plus 1 is 49, so that's 2 times the square root of 49 equals 14. The square root of 49 is 7 times 2 is 14 equals 14, so it checks. All right, let's take a look at example 2. And actually, no. Wait, yep, sorry. I had lost my mind there for a second. All right, so example 2. First step is to isolate the absolute value, so we're going to add 15 to both sides. So we have 5 cube root of 4x plus 3 equals 15. And I think I'm going to use a black marker when I do the exponents so you can see the exponent there. So you see it's not over everything. Okay. Now, we divide both sides by 5, so you get the cube root of 4x plus 3 equals 3. Now you raise both sides to the power of the index, which is 3. This becomes power of 1, so you get 4x plus 3 equals 3 cubed is 27. Now you subtract 3 from both sides, so you get 4x equals 24. Divide both sides by 4, x equals 6. Now you plug that back in to check, so you get 5 cube root of, now this would be 4 times 6 plus 3 minus 15 equals 0. So then that's 5 cube root of, see if we can do the math here, 4 times 6 is 24, plus 3 is 27, minus 15 equals 0. Well, the cube root of 27 is 3, 3 times 5 is 15, so 15 minus 15 equals 0, so it checks. All right, let's take a look at example 3. Now here, first step is to isolate the absolute value, but we can't do anything to the 5, so you just have to leave it where it is. If there's not an index, you know it's 2, so you need to raise both of these to the index of 2. You know this becomes power of 1, so you get 35 equals, that squared is 5. I can write this as x plus 2 to the 1/2 times 5x plus 2 to the 1/2. Because squared means you multiply something by itself. So then you get 35 equals 5 times 5 is 25. And then that's x plus 2 to the 1/2 plus 1/2, which in essence equals 1. So since that's to the power of 1, it's just 25 times x plus 2, so we distribute. So you get 35 equals 25x plus 50. Subtract 50 from both sides, you get negative 15 equals 25. Divide both sides by 25. This becomes 1, so x equals negative 15 over 25, but that can be reduced to be negative 3 over 5. All right, so now we check. And since we know this column's all check, I'm not going to, on a test, you'd write check here, but since we know that the check column is right here, that everything on this column is checked. So we can go to plugging that in. So we get the square root of 35 equals 5 times the square root of negative 3/5 plus 2 . And so then you get the square root of 35 equals 5 . Now, in order to add these, you need to multiply the 2 by 5 divided by 5. So then that becomes negative 3 plus 10 divided by 5. And when you put those in the calculator, the square root of 35 is 5 0.92, and then 5 times the square root of 7 divided by 5 is 5.92, so this checks. All right, let's take a look at example 4. All right, now they're isolated as they can be, so we need to raise both sides to the third power. So this becomes power of 1, so you get x plus 6 equals, that's 2 times x minus 1 to the 1/3 power times 2x minus 1 to the 1/3 power times 2 to the x 1 to the 1/3 power. So then you're left with 1x plus 6. 2 times 2 times 2 is 8. We knew that 1/3 plus 1/3 plus 1/3 is 3/3. So that's x minus 1 to the 1 power. So it's just x minus 1. So then we continue to simplify. That equals 8x minus 8. We subtract 1x from both sides. So that's 7x. And then we add 8 to both sides. That becomes 14. Divide 7 by both sides. So 2 equals x. And then we need to check. So we plug this back in, so that's the cube root of 2 plus 8, or 2 plus 6, sorry, equals the cube, or I'm sorry, 2 times the cube root of 2 minus 1. Well, that's the cube root of 8 equals 2 times the cube root of 1. So 2 equals 2, so this checks. All right, let's take a look at example 5. The index is 2, so we're going to raise both sides by 2. This becomes power of 1, so you're left with 1x plus 18 equals x. I'm going to put 1x minus 2 times 1x minus 2. So we need to FOIL this and leave this alone. So 1x plus 18 equals 1x squared minus 2x plus 4. Now we need to get everything to one side. So we're going to subtract 1x from both sides. And we need to subtract 18 from both sides. So that 0 equals 1x squared minus 5x minus 14. And so we need to factor. We know 1x and 1x. Now, we need to find all the combinations to make negative 14. So 1 times negative 14 is negative 14. 2 times negative 7 is negative 14. 3 doesn't work, 4 doesn't work. 5 and 7 times negative 2 is negative 14. Now we need to find the combination to make negative 5. So 1 minus 14 is negative 13. 2 minus 7 is negative 5. Haha, we have it. So our factors are x plus 2, x minus 7. So then we said x plus 2 equal to 0, x minus 7 equal to 0. So we subtract 2 from both sides, x equals negative 2, x equals 7. Okay. So now we have our two answers, but we need to check. So let's check first, x equals negative 2. So then we plug, that's the square root of negative 2 plus 18 equals negative 2 minus 2. Well, that's negative 2 plus 18 is the square root of 16. Does not equal negative 4. So we know that this is not a solution. Now let's check 7. So when x is 7, that's the square root of 7 plus 18 equals 7 minus 2. Well, that's 7 plus 18 is 25. The square root of 25 is 5. So 5 equals 5, which checks. So our answer is x equals 7. All right, example 6. So now we square both sides. So then that becomes power 1. You're left with 2x plus 14 equals 1x plus 3 times 1x plus 3. So then we don't do anything with this yet. We need to FOIL the right side. So 1x times 1x is 1x squared plus 3x plus 3x plus 9. We need to subtract 2x and negative 14 from both sides. So then you're left with 0 equals 1x squared. See that 6 minus is plus 4x minus 5. So we need a factor. So 2 parentheses. All right. So to find, we need to first find all the combinations to make negative 5. So 1 times negative 5 is negative 5. 2 doesn't work. 3 doesn't work. 5 times negative 1 is negative 5. Now we need to combine to make 4. So 1 minus 5 is negative 4. That doesn't work. 5 minus 1 is 4. That works. Our factors are x plus 5 and 1x minus 1. All right, so you set those equal to 0. So 1x plus 5 equal to 0. 1x minus 1 equal to 0. So x equals negative 5 and x equals 1. Now we need to check. Okay, so let's check x equals negative 5 first. So that's the square root of 2 times negative 5 plus 14 equals negative 5 plus 3. Well, that's negative 10 plus 14 is 4, so we get the square root of 4 does not equal negative 2. So this is not a solution. Now we check x equals 1. So we get the square root of 2 times 1 plus 14 equals 1 plus 3. That's the square root of 16, which equals 4. This checks, so that is a solution. All right, example number 7. So here we're going to cube both sides. This becomes power of 1. So you get 1x plus 5 equals 27. Subtract 5 from both sides. X equals 22. Now we need to check. So we plug, that's 22 plus 5 to the 1/3 power equals 3. Well, 27 to the 1/3 power is 3. 3 equals 3, so it checks. All right, last example. We're going to square both sides. So then you get 1x squared equals, that becomes to the power of 1, 1x plus 12. We need to subtract 1x and subtract 12 from both sides. So you get 1x squared minus 1x minus 12 equal to 0. We know we need to factor. We know it's going to be 1x and 1x. And so now we need to find all the combinations to make negative 12. So 1 times negative 12 is negative 12. 2 times negative 6 is negative 12. 3 times negative 4 is negative 12. 4 times negative 3 is negative 12. Now we need to find the combination to make negative 1. So 1 minus 12 is negative 11. 2 minus 6 is negative 4. 3 minus 4 is negative 1. We have it. So it's x plus 3, x minus 4. All right. So you set 1x plus 3 equal to 0. 1x minus 4 equal to 0. So 1x equals negative 3 and 1x equals 4. All right. So now we check. So let's check x equals negative 3 first. Now, I tend to make a mistake sometimes because I see that squared, so I'm going to erase that. Okay, because I'm going back to the original equation. So negative 3 equal to negative 3 plus 12 to the 1/2 power. Well, that's negative 3 equal to the square root of 9. Those are not equal, so this is not a solution. Now let's try 4. 4 equal to 4 plus 12 to the 1/2 power. 4 equals the square root of 16. That checks, so 1x equals 4 is a solution. Okay, so with that, finish up your examples and start working on the assignment, and have a wonderful Wildcat